Right, good evening everybody. We're going to have another look at the FCU and also some additional settings and how we use Cameo Universal in modules tonight, what it's capable of and what you can do with it. So I think first of all, we'll just deal with a couple of queries we've had over the actual settings in the FCU itself. Now this is version 1.6, which is the latest release, and I'm not sure whether it is or it isn't a default, but there is a setting here under interpret messages, which if you tick it, when you see an event, it will display it in what effectively is as good as close as English as you can get. If it isn't ticked, then all the events will look like this. Now, if you click on one and hover the mouse over it, it will tell you what that event is. But for the ease of use, always have interpret messages ticked. Now, if somebody says to you, use generic dialogues, which you will hear quite a lot with Universal, it is here. It is settings, advanced, use generic dialogues. What that does is it just brings up a box where you can enter node values or event values rather than having to tick or do tick boxes, move sliders, stuff like that. It's useful for some things. Most of the time, just use the FCU as it is. Okay, so what have we got here? We've got two cameos. They're both running effectively the VLCB version of the latest firmware, and they're also both running, if I remember rightly, 27Q processors. So they are not programmable by the FCU. A 26K is, but the firmware, what the firmware does is no different. It's just how the firmware is written. And what you see at the end is no different between standard firmware and VLCB firmware. So when you install your firmware initially, you will end up with a sheet like that when you double click on the node. This is after you've read the node values here by going right click and read node values, and also read the properties by right clicking and going read properties. You right click it and go read events, you will get all these, which is 16 channels down the bottom, and you can select them in number order as usual, just whatever you want them to do. Okay, so the first thing you will notice when you double click on a node that's got Universal in is you'll get this screen. There are a couple of boxes at the top. Cameo 1, that's what I've called it. Startup event delay. This module is capable of producing a startup event, and it is in lots of 100 milliseconds. So if you set it 10, it'll power up, wait a second, and then it will send an event out, and you use that as the start of date message, or as a start of date message. You don't just have to have one, you can have many. The second one, the second bar here, is something that's called heartbeat delay. Now that is a new feature of VLCB. It won't appear if you are using standard firmware. What that is that the module will send out a pulse that says, I'm here, and it is used by analytical modules that keep an eye on the bus that have not yet been, the firmware for which hasn't been written yet. It's part of VLCB, and basically you set it to 0 and it stops it from generating it. So you always want it at 0 unless you specifically want to send a message out that says I'm here every however many seconds you set it to. These are your channels. So you've got 16 channels by default. Depending on what board you are running, they're all in banks of 8. So with a Cameo, you will have 8 on the lower board. That's 1, 2, 3, 4, 5, 6, 7, 8. And on the daughter board, you will have 9 to 16. With a Cameo, and also with the 16 channel V-out series modules, they can be anything dependent upon how you build the board physically. The only limitation there is that you cannot have an input channel where you have fitted a bank of 8 with a driver chip, because the signal just will not make it back through the driver chip to the PIC. So it'll never see it. Apart from that, most channels will do most things. Okay, when you put the firmware in it first time, all 16 channels are logged as inputs. There's a drop down here, and standard firmware, these 5 input, output, servo, bounce and multi are your available options. The other 2, analog and magnet, are available in modules with more firmware space because they take up more space. But the basic default is input, output, servo, bounce and multi. The other 2 are documented on the Cameo Universal pages, but they're not normally used. So we'll go through each channel type first of all. Input, pretty simple. That's the default. You've got 4 options here. You can invert the trigger, have it send on events only, toggle the event state, or invert the event. Now, trigger inverted refers to the signal that you are applying to the module. So an on, without that being ticked, will be treated as an on. With it ticked, it will be treated as an off, and vice versa. On events only here, that generates just on events when it sees a trigger. Toggle the event state. That's very similar to trigger inverted, as is event inverted. Event inverted is the event it sends out. Okay, so which module am I on? Cameo, which one am I here? And then this one. Yeah, right. Well, yeah, 319. So if I select the channel 8, let's move that across if I can. There we go. When I press event 8, you'll see that I'm going on when I push the button in, off when I release it. If I tick event inverted and save it by going save channel finish, display the messages. When I push it in, it produces the off event. When I release it, it produces the on event, which is the inverse of what it would naturally be. Every time you double click this to bring up this box, it will always start with channel 1 selected. So if I click channel 8 now, you'll see it's remembered because I saved it that the event was inverted. If I tick it, untick it should I say, and save the channel and then finish, it will write those details to the module. You must write the details to the module. If you don't, the module will still carry on its merry way doing what it was originally. Until you tell it something, it won't do anything. Okay, so the delays for your on and your off, they're for things like to stop switch bounce, that sort of stuff. You can delay how long it is before it turns itself on, how long it is before it turns itself off again. They generally, the default is 20 milliseconds. Most of the time, they're quite happy left like that. If you've got them connected to totties on where locos are running around, you might want to extend the off delay slightly, and you might want to bring the on delay down slightly. Putting them at 0 can lead to false triggers, because as soon as it sees a bit of noise on a line, it will trigger and will send an event. Okay, next type is output. Okay, now it gives you a warning. What it says, obviously, is on the screen, that if you change it, it'll erase all the current settings for that particular pin and default for. So the answer is, if you want to change it, the answer's got to be yes. Okay, so you see we've got different events now, different triggers. Okay, so trigger inverted, same as before. Event inverted, same as before. Action expedited, that you have to understand with universal that anything it does, it places in a queue. So if you are running a servo and it is going from point A to point B, it will want to do that and won't do anything else until that process finishes. So if you are running it really slowly, you might want to turn on a frog at midpoint. If you don't tick action expedited, which effectively says move it to the front of the queue as soon as you see it, then what will happen is that it will quite happily carry on, move the servo all the way across and then do it. Okay, by which time you may create a short if you've got something sat on the rails. Okay, the one above it, restore state at startup, pretty obvious really. You tick that. If it was on when you turned it off, it will come back on when you turn it in the on state, when you turn it back on again. On events only, same as before. The action inverted, pretty much the same as before. Now, with the output, you can have steady state outputs, which is 0 and 0. You can have a pulse, which is a single pulse going out, or you can have the output flashing on and off. Okay, most outputs on the current PICs are capable of driving low current LEDs. So if you have something like a bank of LED isolated relays, you don't need to fit a driver chip to drive them, because you're not driving the relay directly, you are driving the LED. And if it's just one LED, then it's the PIC is quite happy to do that. Okay, and then we go on to servo. Same warning again. Same things, trigger inverted. 1 second cutoff. What that says is when you've got to the end of the travel, stop sending the pulse signals. Otherwise, it will sit there trying to move into the final position ad infinitum. Okay. Move to save position at startup. Same thing. Event inverted is the same thing. Power up high. Now, this is a new one that Ian's put in. There is some discussion over servos pulsing when they are powering up, and servos moving in an uncommanded way. Some people say you should power them up low. Some people say you should power up the signal lines high. So the defaulting Cameo is to power them up low, unless you tick power up high, in which case it will put the signal line as a high signal, as in, I think it goes up to about 5 volts, I think. Okay. Each position has its own 2 sliders. One is the speed at which the arm moves to that position at, and the other one is its actual position. The defaults, they only offer the same, and the on speed and the off speed are the same. Okay, you will also see up here we have another box, show all slow servo speeds. You will notice if I move this servo down to here, it starts at 230 and it runs up to 255. That's the majority of the ranges that you would use, but the servo calculation that it uses for speed is a logarithmic graph. And if anybody wants to remember back to logs at school, the graph is basically, it's a half a parabola. If you tick that box, you will see that they come all the way over here, and 230 is there. Okay, if you put it down here and put it on 20, you could go away, make a cup of tea, go to Sainsbury's, do the shopping, come back, go to the cinema, and if you're lucky, your servo will have made it to the other end. That's just how it works. It's the timing between the number of pulses between each pulse that controls. So it's best left unticked unless you really, really, really want to sit around and watch paint dry. Okay. Now we go on to these two. Bounce. This is basically, it is a servo. So the same thing applies, all the tick boxes. It's for driving semaphore signals or anything that you think the movement of it should look like a semaphore signal. In other words, when you pull a signal, for those who know how semaphores work, when you pull them to pull the signal on or off, as the arm raises it, generally it goes halfway and then it would go up to the top. As it drops, it will bounce at the bottom. But as X-Signalman will tell you, it only bounced at the bottom when the supervisor wasn't around. Otherwise, it would just act perfectly smoothly. What the bounce coefficient does is it simulates that with servo movement. It is reasonably realistic, but you can play about with it. You can see you've got pull speed, pull pause, the bounce coefficient. All those top two determine what your arm position is going to be. All these other three are to do with how it looks on the way up, and the bounce coefficient is what it does on the way down. Okay, final one of the 5 is multi. Now what this is each servo can have 4 positions. That position value is between 0 and 255. Now, depending upon which EV you set, the servo will move to that position. This one sets, I believe, the starting position. Okay, all these ones here are the same. So how do we set up a servo? Okay, so first of all, we need to pick a channel. So we're going to pick channel 1. So we'll select servo, get that warning again. Okay, so the first thing we have to do is tell the FCU that we want it to be a servo, and then save it and write it to the module. Because until you do that, if you want to change those sliders and see what it does, it won't do anything until you've told the actual module that that channel is now a servo. Okay, so we'll go back into it now. And as you move that, the servo now moves. I can see the servo moving about as I move that slider. If you increase the speed, when you use these two buttons here, you have test on, test off. The faster you move that, the faster the servo moves. Okay. So when you're happy with the positions, there again you go, save channel, finish. So that's your servo set up. So what do we do?
I just ask a question there, Tim? Sorry to interrupt your flow. Can you type the value into that box on the right? And can you also use your arrow keys on your keyboard if you highlight the slider for fine control?
You can type that into there like that. So if I want to put 140 into there, you see the slider moves. Yeah. I'm not sure. It does. If you click on the slider itself and hold the arrow keys on your keyboard, it will move. Right. So you save the channel and you finish. Okay. So what we now need is we need an event to teach that. So what I'm going to do is on this other module, which is, that was module 319, which is this one we've been playing with. I'll just do the same thing on there. Set that as a servo. It's already set up. Test on, test off, save channel, finish. Okay, we'll use one of the inputs on this module, one of the buttons. So if we use button 8 here, and we come down here, and we find channel 8, event 8, produced by that cameo. Okay, which is there, you can see at the top left. You then drag that. So by drag and drop, what you do is you move the mouse over it, hold the left button down and bring it up. And when the pointer is pointing over the module you want to teach it to, release the button. Okay. What that says is we are now going to teach module 2, event 8, and then you get this box below. Now, for those of you who've used generic dialogues, you will know that you never used to start with EV1, you always started with EV2. So there's a produced events tab and a consumed events tab. Produced events is for self-consumed events, which I'll cover in a minute. Consumed events is for everything else. Okay, so we want to operate, this is pin 1. And it will tell me that pin 1 on that particular module I'm teaching the event to is a servo. I also need to specify the EV number, so that's EV2. So you go EV2, channel 1, and then you get this box, this drop down below. Now there are four options. Change. What that basically says is when I see an on event, I go to the on position. When I see an off event, I go to the off position. Not change is logical not. So on goes to the off position, off goes to the on position. On will just go to the on position, off will go to the off position. So for this purposes, we're going to put change. Accept, and you will see when I go accept and OK, that it then goes away and it writes 20 event values. Now, if we look here, event learn, node 319, event 8, index to value 8. Now, if I come and look there, you can see that when I go down, I've got Cameo 1. That refers over here. Event 8, that's the event we taught it. The event value, that is EV8. That is EV2. Okay. And that's where the events come from. And that was the number, the event number in that particular module that sent it. So now, if I go back to this one and I click event on and off, because it was already in the on position, it didn't move first. Because if it receives an on and it is in the on position, it ignores it. Same thing with the off position. So clicking off, it's moved. Click on. That will then move. Now, you will notice in this module here that we have gained 3 events. We've gained 101, 201, and 301. Those represent the end travel positions and the midpoint position of that servo travel. So as it leaves, if you look, just clear that, and I'll move the servo. Okay. And you can see here that we've got node 306, which is where the servo is connected to now, producing an off event for 201. And it produced the off event as it moved away from that position. 306 is the mid position. Now, one way will produce the off, one way will produce the on. And an on position when it gets to the other end of its travel. So, just press it and hold it. So that's me sending it back the other way. Off from 101, on as it goes past the midpoint. And that's it arriving at its initial start point. If I release the button and send it back the other way, it does that. Okay. So you notice that because I'm using a push button there, what I ideally want is one push to send it one way and another push to send it another way. So if I come in here to the module that sent it and I select channel 8, which is an input, and I highlight toggle event state, save, finish. Okay. Next time I press it, one press sends the on event. Now I've taken my finger off that button now. So until I press it again, it sends the off event. That's what toggle event does for you. It's very similar. In fact, it's exactly the same as what you would get with the CANimp module, where you select toggle push button event. That's what it's there for. It's not necessary if you're using a switch, but it is necessary if you want to move a servo. Otherwise, all the servo will do, it will move across, get to the other end. As soon as you take your finger off, it's going to go back to where it started from, which isn't particularly useful if you're driving a point. Might be if you just want a little man to wave a flag once, or something like that. But generally, no. If you're using push buttons, you want to be using them as toggles. If your push buttons are driving points. If you have two push buttons driving one turnout, as in one push button drives the servo one way, one drives it the other way, then what you would do is you would teach one event to drive the servo to the on position and the other push button to drive it to the off position. So we'll just have a quick look at that. So we'll use this same module here, 319, and we'll use event 6 and event 7, channel 6 and 7. So if I double click that and I go to channel 6, so we're going to say, I want you to send just an on event. So I will tick that. Yeah. Save it. Now you can go on and configure channel 7 as well before you click finish, because it saves the channel, but it doesn't actually write anything to the module until you click finish. So we're going to go to 7 now, and we want it to send an off event. So what we do is we tick on events and we click toggle event state. So you go save channel, finish. So it's written those. So now I'll just clear those messages. We'll see that me pushing event 7 has produced non-event. That's also produced a non-event. So I've done something wrong. Let me go back into it and have another look. It always gets me, this does. Toggle event state, you haven't ticked that. That's why. No, it's not doing it. There you go. So that is now sending off event, and just off events on event 6. That is sending on events on event 7. Yeah. I've just touched 8, so the servo's just moved. So if I was to now take event 7, teach that to pin 1, and that was event 7 was the on event. So I say that's an on event. Accept. Okay. Let that save it. Event 6. Same thing again. Go to event 6. EV2. Pin 1. And that's an off. Accept. And that should clear these messages. Okay. So what you can see there is me sending event 7, which is the on event, and it moves one way. Sending event 6, which is the off event, and it goes back the other way. So that's how you do 2 push buttons. Okay. So What can we do with these, say, these midpoint events? Generally, these are used for things like in the frog relays is one use. You can also use them if you have got suitably wired bicolor LEDs as point position indicators on a panel. It's anything that would change as you go past a midpoint. So if we say we wanted to operate a frog relay, now you can do it quite simply if it's on another module. Because all you do is you find the module with the servo bits in, 301. So you take that and just define channel 2 as an output. So that's just going to switch on and off. That's on the other module. And it's simply a case of select the midpoint event, drag that, drop it onto that event. Now we set that up as channel 2. So we will go EV2, pin 2, which is an output, and the output effect is change. Now you will see here that you have got 5 options with this. Change, not change, we've explained before. On event, that is generally used when you want to send a pulse flash, just one pulse. The flash command literally turns the LED on flashing or off flashing if you've got the channel set up inverted. And not change, we've explained before. So we'll accept change, accept, okay. So now, when I send that, you can't see it, but the LED has changed. When I send it back the other way, the LED's gone off again.